In 2013, Elon Musk unveiled a new mode of transportation, which people call the Hyperloop. People also refer to it as the fifth mode of transportation. The Hyperloop itself consists of a tube that is made completely vacuum and a pod that levitates inside the tube. Because the tube is vacuum and the pod levitates, there is no atmospheric resistance or frictional resistance, and the pod is able to accelerate from a low velocity to a high velocity in a very short amount of time. This enables a very efficient and quick mode of transportation. The Hyperloop consists of wheels, brakes, and different suspension systems that enable it to perform the way it functions. Using air-bearing cushions or magnetic levitation, it levitates, and while it's in a static stop position or in a station, it uses a deployable wheel system. Our team was inspired by a line of text in Elon Musk's Alpha document that stated that the Hyperloop system would consist of a deployable wheel system for the load speed requirements and also for emergency scenarios of the Hyperloop. The Ryerson International Hyperloop team developed the Hyperloop deployable wheel system to fulfill the low speed requirements of the Hyperloop and also for emergency scenarios. That is to say, when the Hyperloop is approaching a station or coming to a rest or moving at very low speeds or also doing emergency scenarios, the deployable wheel system extends and enables the Hyperloop itself to balance on the wheel system, similar to an aircraft's landing gear. With the support of our corporate sponsors such as Cadenis Parts Solutions, the Aerospace Industries Association, and the IHS Markit, we were able to win the Subsystem Innovation Award at the SpaceX Hyperloop competition in January 2016.
When you break down our design, in fact, you can see that out of over 200 parts, over 160 of which are actually standard parts off the shelf. And of that 160, we used over 120 NAS/MS parts that are part of the AIA's 3D digital database created by Cadenis Parts Solutions, available on IHS Markit. In fact, the AIA NAS standard parts represent over 58% of our total part count. Using these resources, we accelerated our design process and we were able to get 5 units finished in less than 1 year. That's from initial concept, paper design, to actually testing full systems in a landing gear test facility just outside of Toronto, Ontario. Well, using Cadenis Parts Solutions 3D digital database, it allowed us to compete with larger teams in the Hyperloop competition. We were only a very small team of 6. Other teams were formed 50 to 100 students. So we were at a big disadvantage, but having access to that 3D digital database allowed us to not only increase the quality of our design by using aerospace standards, but it also allowed us to work very quickly, experiment. We could drop parts in, swap them out very quickly without the effort of remodeling and changing the parts ourselves. So we're very grateful for their support and we hope to work with them in the future.